be the consequences of moving a waypoint. All routes in an area are drawn on the chart screen. In addition, an overview of all pre-programmed routes in this area is displayed in a list. The navigator can select a suitable route for the voyage from this list. Specifying the waypoints can create new route plans. In addition, new route plans can be created based on existing plans. Create a new route by making a copy of an existing route and then modify it. Reverse an existing route. When a route planning process is completed, it is not only recommended but also good seamanship to require that the route be validated. This implies that the system checks that the route with off-track limits does not cross the safety contour. Some ECDIS systems on today's market can import and export electronic charts and routes to and from integrated navigation systems. Press the red square to install charts. The safety contour is the most important safety features found in an ECDIS system. A safety contour is a line in the chart that defines water with safe depth in relation to the actual ship. The ECDIS system continuously checks if the ship, within a specified time, may cross the safety contour, and if so, give alarm. The navigator can choose a depth contour as the safety contour, or he can specify his own safety contour. Press the red squares to change the safety contour. When powering up an ECDIS, the system automatically starts in route monitoring mode and displays own ship's position on the chart. In this example, the chart is displayed in night colours with north up. This is the standard ship symbol used on ECDIS systems. The direction of the course and speed vector connected to own ship symbol is the course and speed made good. The length of the vector is proportional to the speed of the ship. Each line segment represents 1 minute. When the ship is shown in true scale on the chart, the concentric circles are substituted by the contour of the ship. Own ship is by default located in the centre of the display. The operator can change this position. Additional information may be presented in a separate window called General Information. The navigator can turn this window on and off. The following information may be displayed in this window: date and time, chart scale and original scale, elements included in standard display, current route with data for active waypoint, range and bearing with positions, chart, units of measurement, depth and heights, ENC date, datum, last update of original chart, various mode data, messages. As default, the chart on the screen is orientated north up, and the ship moves in the chart the same way as on a north stabilized true motion radar display. A scale bar is always shown on the chart. The navigator may find course and distance from the ship to any point in the chart, or between any 2 points in the chart. In addition to course and distance, the positions for the points are presented. The navigator may display all available routes on the screen and select a suitable route for the voyage. All data about the waypoints are presented in a waypoint list. During sailing, the navigator may introduce changes to the active route. The electronic chart is object-orientated. This means that when the navigator selects an object in the chart, all available information in the chart database about the selected object is displayed. The navigator note function can be looked upon as the navigator's second memory. The navigator can point at a navigator's note symbol in the chart and get the information connected to that symbol displayed on the screen. The navigator may introduce new notes in the chart by pointing on the required position for the new note and type the actual note text. The ECDIS system is required to receive input from the best position sensors available at any one time. However, when the automatic position sensor or sensors fail to provide input to the ECDIS, manual specification of data is possible. Whenever manual input is used, information given by the ECDIS must be used with great care. A number of parameters can be changed in monitoring mode. Here are some: grounding alarm time, ship vector length, ship bearing line length, past track to be displayed, past track time label interval. When an off-track limit is defined for current route, an alarm will be given to the navigator whenever ship's position is outside this limit. If own ship's position, course and speed is calculated to lead to a grounding, an alarm will be given at the time specified, for example, 6 minutes prior to the expected grounding. On most ECDIS systems, tracked targets provided by an ARPA system can be displayed on the ECDIS screen. Targets from ARPA are shown on the ECDIS display with its own symbol. Normally, there is a limit to how many ARPA-derived targets that can be displayed on the ECDIS. There are ECDIS systems on the market today that can handle 50 ARPA targets. On the following pages, you will be asked some questions. Your answers will only be logged the first time. So if you want to repeat anything, return to the menu.